As the demand for ultra-fast, reliable connectivity continues with broadband service providers, we'll look at the transformative shift in ways that they're looking to improve their networks. From the multi-gig broadband era, convergence of fiber plus DOCSIS, and network virtualization and service assurance. Let's dive in. Thanks, Thuy, for joining us today. Today we've got Thuy Nguyen with the head of the cable segment of Intel. So Thuy, tell us a little bit about yourself.
Hi, Dustin. It's great to be here. I appreciate you giving me the opportunity to join you on this podcast. About me, I started into cable in 1993, straight out of university in Toronto. And I was fortunate and joined a small Skunksworks team at Rogers doing cable modem. And at that time, we didn't know what a cable modem was and what the internet was, to be honest with you. And, this group said, hey, you want to join and work on this thing called the internet? Internet wasn't a very common term for a lot of people back then. But, it's come a long way. So, we launched the first cable market in Newmarket, Ontario in 1995. And I came to California in 1998 to work for a company called At Home Network. And then, I've had the good fortune to work in cable broadband, throughout my career. So, I've gone to work for Rogers and At Home and Comcast, and I've worked for vendors, working to sell solutions to the various cable operators. I've worked for Cisco and Alcatel-Lucent, which is now Nokia. And I joined Intel in 2018, so 7 years ago. And I was very excited to join Intel because we were embarking on a journey to virtualize the CMTS. So it's been a great journey for me, and I'm very happy to see the cable broadband journey as it has taken shape in the past 30 years that I've been in.
Yeah. Well, thanks for your introduction. I think I met you probably in, I think around 2022 at one of Harmonic's customer events. Intel is a close partner, in talking about virtual CMTS aspect, and Thwy's been around for a very long time. And, I think I'd mentioned in one of the other sessions that I joined the cable realm around 1999. So Thwy's just been in it, 1 or 2 years, and so have I. So we appreciate your time. We know that time's valuable, and, I think we're going to have a lot of great discussions today as we kind of talk through different segments of the show today. So, looking at what's happening in broadband, and, everyone's trying to get more bang for the buck, right? Really getting faster speeds, lower costs to the consumers. And, what is, your thoughts around how we can empower operators that need to get to multi-gigabit for the next generation of customers?
I don't know that it's empowering. I think they have all the tools that are needed, and the DOCSIS standard has been a fantastic standard that continues to evolve, and the operators know what they can do and will do in the coming decade to be able to offer multi-gigabit speeds, right? So the beauty of the DOCSIS network is that it's not distance limited, right? So with amplification, they can carry the last mile that is run over RF, quite long distances. So, for the most part, a lot of their networks are already on fiber running Ethernet to, that node, right? They call it a node, and in, some places they call it a secondary hub. They just need to increase the spectrum capacity of the plant to be able to pass more spectrum. So whether it's, 1.8 gigahertz in the DOCSIS 4 realm, or, what comes after DOCSIS 4.0, the ability to give more spectrum to the upstream to be able to deliver multi-gigabit upstream, and the multi-gigabit downstream that is capable today with DOCSIS 3.1 and soon DOCSIS 4.0 and beyond. It's upgrading the passive equipment such as the amplifiers and the line extenders, and upgrading the taps, buried underground or up on a pole in customers' homes. That'll pass more RF signal. But in terms of what we do, Harmonic and Intel, is we digitize, that DOCSIS signal to run on off-the-shelf compute, right? CPUs and servers, rather than relying on a CMTS that, has a much longer shelf life and a longer development life cycle. And so, I think MSOs are able to take more control, have more flexibility, have more options at their disposal to deploy, a 1U or, a 2U server, and they can, add more servers to add capacity on an as needed basis, rather than buying, a fully integrated CMTS that has line cards and downstream, upstream ports with a certain amount of capacity that is limited, by the, amount of throughput that it can do. With a server, just like the data centers that, the web scale companies run, you add more servers, you add more, NIC cards, and you add, more Kubernetes pods, in cloud native speak, as you need it. So I think DOCSIS and the cable companies are in a great spot. Not only is it cost effective, I think it also gives them that just-in-time compute. They don't need to buy compute that can last 10 years because they can, apply more compute on an as-need basis.
Yeah, and I think just while we're on that topic of things, when we're talking about the compute aspect, and just kind of the traditional methods that operators are deploying, right? There's other operational benefits around changing some of the function from your legacy CMTSs to a virtual CMTS, rack space, because of just the technology of doing it on a server, right? Not to mention, you were talking about where we would push the DOCSIS further out in the network. And when you talk about that, you talk about traditional lasers that are removed. You don't have all those laser banks in your head end anymore. In a lot of cases, the RF combining is completely diminished. So operators, depending upon their size, could save, a considerable amount of rack space, power, heating and cooling. I see a lot of operational benefits around, what's happening in the world today with virtualization and for that multi-gigabit broadband era, right? Everybody needs the next latest, greatest technology. Just so happens that being able to virtualize that really controls a lot of what happens to your operations in the future. So, traditionally, looking back at the cable space and a lot of the things that have happened over the last 20 to 30 years, there's been a lot of chassis that have been picked up from a system where you put it in 3-4 years later, you're pulling it right back out, you're putting in the next latest, greatest thing. I think, going to virtualization really helps with that deployment method for the operator, because it really extends the life of what they're doing inside of the compute aspect of the servers that they're able to deploy.
Yeah, you're absolutely right, Dustin. And I think one of the key stepping stones is the disaggregation of the PHY and the MAC, right? And the DAA, the distributed access architecture that was invented, 15 years ago, right? That allows you to run the remote PHY in a remote location where you don't have to pull that RF signal back into the head end and do all of that RF combining and, the muxing of the lasers in the head ends. That just wouldn't scale if you're talking, 10 gigabit per second service groups. And of course, I think the great thing, as you mentioned, is, I've done some of these studies with, tier one operators in Europe and in North America. They're talking savings in the realm of, 20 racks being reduced to one rack to do, in the head end, just the layer 2 MAC function, because they're able to leave the layer 1 PHY function out in the head end, outside in the outside plant. So the head end is only doing the Ethernet MAC processing. And so that saves a lot of rack space. It saves a lot of power and cooling. And so, at the same time, at the capacity their networks grow, they're, also becoming greener and consuming less power.
Yeah, talking about pushing the PHY out there, and the DOCSIS generation piece, other things that it can help with that I think a lot of operators don't consider is permitting. A lot of operators like to put hubs or cabinets on the side of the road, and that takes permitting. You've got to get property to put that on. In a lot of cases, you got to get power to it because maybe there's not electricity available there. Being able to have a product or multiple products that you could deploy on a strand and push that aspect further out, you could actually decommission a lot of hub sites, cabinets that you might be using just for those purposes. I know of several operators that their cabinets pretty much look like a small head end, and it's just replicated over and over and over. But when we're talking about the deployment methods with virtual CMTS and DAA, you can take a lot of that compute aspect, bring it back to the head end, and then put minimal equipment in the field to do the same job as what you've been doing for a lot less cost. So, I see a lot of benefits in that. And, the kind of in a different aspect with virtual CMTS, there's other things that can be deployed inside of a virtual CMTS instance when we're talking about changing it to virtualization and leaving the compute into the CO head ends. Fiber plus DOCSIS is, we know everybody wants to get to, they're looking very heavily at fiber today. We know that a lot of operators have not only DOCSIS networks, they have fiber networks as well, because, that's kind of where they're wanting to progress. So being able to virtualize things allows you to be able to kind of have the best of the both worlds. What's your thoughts around, doing PON plus DOCSIS out of a system like what we're talking about?
I really think that the cable MSOs have a strategic advantage there, right? Like, a lot of people may know that MSOs have a lot of fiber, and they've always had a lot of fiber, right? And these fiber nodes that they run at the secondary hubs are serviced by fiber. And I think I read a stat somewhere that the last mile that is RF or coaxial cable is now maybe around 1 mile or less, or even a kilometer in length. So what they choose to come out of those secondary hubs or fiber nodes for access is entirely up to them, based on the economic return of, the investment to get to your home, right? So the beauty is the MSOs have that option. They can either run a DOCSIS 4.0 modem in your home with existing, RG6 or, coax cable, because you already have that in your building or, in the ground, in your tap.
Yeah.
Or they can run, a fiber line to an ONT to the side of your house. And I don't think consumers really care what medium they're using in, accessing their broadband these days. And the MSOs have that option of running either or. Both are capable of 10 gigabit per second, downstream speeds. And, if you need more than a gig, both services, whether it's PON fiber or, DOCSIS, can deliver that today. So that journey is different for operators based on economic conditions. Right, and I'll give you the example of, in North America, we have a pretty geographically, diverse environment. And so you've got more rural and suburban and obviously some urban markets. Whereas in Asia, especially in Asia Pacific, right, where we've seen DSL thrive and fiber to the home thrive because of the population density and the high-rise buildings. They run fiber to the bottom of the building, and they just, run, on throughout those, apartments. And that economically works for them. Trenching to homes, fiber lines in suburban, North American markets may be cost prohibitive. So they'll apply that playbook of cap and grow DOCSIS to move to fiber as they need to get the investments they need for, average capital per unit or per customer, or average revenue per unit they get after that initial installation, accordingly. And then I'll take other markets, such as South America as an example, right? I think they have different labor markets, and they may have some different government subsidies that accelerate their timeline to do PON fiber. But in the beginning, they don't have to rip all of that cable and DOCSIS equipment out right away. They can run DOCSIS and deliver multi-gigabit service until they're ready to make that move. And, maybe in North America, the cost is, I don't know, maybe $600 per home to run fiber to a home. Maybe in South America, it's a fraction of that. Maybe, a quarter of that cost. And as such, they're willing to jump in sooner. But the transformation of that network in that last mile with virtualizing, the CMTS and virtualizing the VBNG makes that option flexibility a lot more, advantageous for MSOs.
Yeah, there are a couple of considerations, talking about virtual CMTS, which is different than the traditional RF designs from the analog lasers, digital return. One thing that once you go to virtualization and you're running DAA in the field, something to consider for operators out there that have a DOCSIS plant that aren't doing fiber today, or maybe they have some fiber and they're doing it in different methods than kind of pairing it up with their virtual CMTS instance, or maybe their legacy ICMTS. There are products out there that are, you would have the node running on DAA with a virtual CMTS, and you could use that same 10 gig input that we're using for that node to actually deploy fiber out of that same housing, while simultaneously deploying DOCSIS to your customer, multi-gig DOCSIS to your customers. And as you needed, you could, deploy PON, in what we call the term surgically, right? Surgically deploy PON. There's pluggable OLT products out there today that we pair with a lot of products that allows the operator to do it at their time and leisure and expense, right? Because that's really the biggest advantage to MSOs that we see. They already have the infrastructure in place. They already have the DOCSIS provisioning in place. DPoX could be used to provision ONTs, ONUs. So the barrier to entry is they've already done it, most of it. Like it's a very minor fraction of what they've already done that they need to do to deploy the PON on top of it. So it's just something to consider. I know there's going to be operators, you guys are going to be watching. You're either a tier 1, a tier 2, or a tier 3. I think it's a really big advantage for all MSOs, even some telco deployments, right? That are maybe we see it a lot in North America, where maybe a telco's bought a cable operator and they've absorbed their network, and they have this network there that they go, we're not going to put any investment into it because we have this other PON product. However, I think the other flip side of this is that just needs to be considered is you can make minor changes to that MSO platform that are just small incremental costs compared to a PON deployment that can get your customers multi-gig speeds in a very, very, very short amount of time. Depending upon the deployment size, we're talking even as quick as 60 to 90 days. So moving to fiber plus DOCSIS, I think plays a big advantage for anyone that has either or. And like we was saying, if you've already got that DOCSIS plan out there and you really don't know what to do with it, and you're really stuck on, should I deploy or overbuild it with PON? There are a lot of things that you can do with that plant that can really benefit your business, generate more revenue. Maybe it's someone's overbuilding you and you don't have the resources to build it with PON and compete with them that direction. We can help, in that process. Architecturally speaking, virtual CMTS is the way to go. Looking at the future aspect and roadmap for what's happening in every business practice across the world. So, Thuy, talking about some of the things that you see that could be changed for operators or make it easier for operators, looking at it from the Intel perspective, kind of give us kind of an overview of what you see, the evolution of maybe what they're doing in their network today that maybe they've been doing for the last 10 to 15 years, to get them to be able to put in a solution to get them, 20, 30 years of life out of it. Right. I think I think there's no secret that everybody in the industry, including myself and yourself, are not getting any younger. Right. We don't want to keep working and reinventing the wheel every 3-4 years. So give us kind of your take on what operators could do in regards to fiber plus DOCSIS to give them a length of operational ease to where they're not having a forklift.
Yeah, if I were to think of that journey as you described, that context or that line of question, I look back to, I remember it was 2003 or 2004, so 22 years ago, right? I would ask some folks that I attended, conferences with, how many customers you're serving, right? And back then, at that time, I was working, for a tier 1 operator in the US. And we were in the realm of, single digit million subscribers, right? And back then, maybe each household had nearly 2 email accounts per, household. So, back then you buy your email from that, ISP that you got your internet service from.
Right.
So you're talking around, maybe 12, 13 million email accounts. But back then we were still having issues with reliability of the servers that, were serving the mail, the storage arrays that, you store your messages, and, the front end servers that, house your headers and, indexing, your mail and stuff. But things were still breaking because the world hadn't seen that much email floating around, right? And then I remember attending a conference with some Asian partners, and one operator said they had 180 million subscribers. And I thought, oh my God.
Yeah.
If,
how do you help that, right?
Yeah. And I thought, oh my God, I thought we were having challenges with scaling, right? And we were dealing with 5-6 million subscribers at the time. And here I am talking to an operator in Asia Pacific, particularly in China, and they said they were dealing with 180 million, customers. And I just thought, oh man, like routers and switches, back then are just appliances, right? And same with servers that are running bare metal Linux, and you can't imagine, how do you scale to that that rate. And then you fast forward, maybe a decade, and then you have the likes of Facebook coming on, right? And I remember when Facebook started, ramping in 2009, 2010, they were serving 1.7 billion users,
Wow.
right? So when you talk that kind of scale, you knew that the technology we had at the time with servers and switches and routers just weren't going to scale. So these web scale, companies like Google and Facebook and Netflix had to come up with a better way. And so I really think that the containerization and then the cloud, computing eras came along because of that necessity, right? When you're scaling to be able to service 1.7 billion end users or active users per month, and they're posting, pictures of what they ate for dinner, and they're posting, doggy videos, and you have to store that, you have to present that, you have to quickly get that information to display. So I think the containerization and the cloudification has made that possible to scale. And I think as we apply that to the comm service provider market, they see that that's what they're going to do themselves so that they can scale, they can reap the economic benefits of, that flexibility. And if I were to just give you an example, right? If you look at the routers and switches, like if you look at an analyst report and see how many of those devices get shipped every year, right? You're talking maybe in the tens of thousands of devices, right? Now, if you look at a CPU that powers a server, which now serves a virtual CMTS or a BNG or, an AGF, I believe Intel and AMD and everyone combined, you're talking shipments in the hundreds of thousands per year, right? And to date, you're shipping millions of those units. And Moore's law applies to the point where you're almost getting double the performance every 2 years of performance, right? A piece of silicon or a CPU that you pay typically the same price for, and it consumes about the same power, it's doubling in its performance,
Right.
twice, right? Every 2 years. So that's the level of scale that's possible with Moore's law. And the hardware growth is on that Moore's law trajectory. But what needed to happen was this cloudification, right? Where now you can turn up a pod, right? And a pod may be only a fraction of the CPU cores available on that CPU, right? Maybe that CPU has 32 cores on it, but you're only going to create a pod with, I don't know, let's say 6 of those CPU cores. And that in itself has its own IP address, just as if it was running a server or a router back in, the 15-year ago timeframe. And it has its IP address. It has its very functional, piece of the puzzle to deliver service in the service delivery chain. And so that, I think, makes the scaling possible. And I believe that that's what was needed for the web scale to happen. So as we think of running PON, fiber, DOCSIS, I'm sure fixed wireless access, any access medium, as you go to common off-the-shelf servers and the CPUs to deliver, the compute needed, operators have the flexibility, they have the economic benefit and the scale aspects to make that possible. Now, there's a challenge with that, right? The skill set needs to catch up. And I've seen cable operators myself evolve their workforce 3 times already, right? When I started in the 90s, cable companies were primarily RF coaxial experts, right? We delivered downstream TV signals, and that's, what we were good at in the cable companies. Then in the late 90s, with the help of, some Silicon Valley startups, we became TCP IP routing and switching experts, right? We knew how to run IP networks now, right? Cable companies, that is. And then we took on owning the content, right? hosting websites and email and, voice over IP
Even
applications.
video content.
Correct, right? And digitizing that video content and making that digital content available over IP. So in order to do that, the transformation of the workforce, again, became, Linux and Unix experts, right? And content experts. And, fast forward to, 2018, 2020, that transformation now requires the MSO skill set to be able to do cloud native applications and containerization and virtualization experts. So we've become software defined networking, companies. And so that transformation is in progress. It's still moving along, and, some have, accelerated that skill set transformation, faster than others. But I think that's the next, era that will help move our industry.
You mentioned SDNs, and one, compared to legacy products, in this, it all goes back to virtualization and what we're able to do with the pods, CPU pods, and all these different things. DOCSIS or PON, there's a lot of products that can be introduced into the environment that can help the DOCSIS nature of the whole deployment strategy. Tools such as traditional PMA now become a traditional PMA on steroids, right? It's something that can easily scale. It can do some AI-like features to prevent problems in the network and clean up and demodulate or modulate cable modems on the fly. There's just a lot of different things when you talk about virtualization that can really play in the operator's advantage. Now, I did mention this earlier, but the cost of ownership of a legacy ICMTS specifically in a virtualized environment are greatly different when you look at the TCO for each over even a 1 to 3 year period. Most of the time it's at least a savings of 60%, and in some cases it's even further, right? Depending upon how many of those, we have customers that we'll get in discussions with that maybe they're a smaller company, they have 5-6 hubs. They've got all these individual chassis and individual products, even outside of DOCSIS with fiber, that they have all these different chassis deployed at each head end. Well, speaking specifically to virtualization and DAA, you can take all of that and put it in one head end, and then all the additional hub sites can have just external hardware that doesn't have all the compute on it, and allows them to get all those chassis and all that SLA and power and everything else that go along with them. And it can reduce that too. So I think it's, you can look at it in many different ways, right? You can look at it on the deployment side of things, the operational for your technicians on what they have to actually maintain on a day-to-day basis. And in a lot of cases, the virtualization of it can simplify the network for the operators. So I think there's just a lot of, and we probably could sit here and talk for, an hour or 2 hours about all the different operational benefits of going to virtualization. But there's just so many that I think we, being in the business and being in the day-to-day, we discredit some of the things that are really, really important to operators. I think even operators, if myself, I was in a smaller company, and, we were kind of stuck in our rut, right? Of, hey, this is our deployment strategy. We don't really have any reason to change it. Why would we change it? Well, short story, there was this company that came along and told us and showed us the operational benefits of it. And then we deployed it. It was a virtualized solution, and man, it was it changed our whole deployment strategy. It changed all of our for the technicians in the field. It made a lot of things easier for them. So changes. I guess the important key to this is change is not always a bad thing, right? So I've seen it across many, many companies. And Twee, I know you've seen it, in what Intel's doing with all the different operators that you guys do business with. So, you know, leaning into more of what are the operators when they're looking at the solutions that you can provide today. Um, you know, kind of tell us about the service assurance. What are the key benefits in service assurance that you can do with virtualization versus the historical plan for what most companies had before they went virtualized?
I think it's a great question, Dustin, and I'm glad you asked that because to me, virtualization just gives you a lot more compute. That bubbles it down for me, right? If I give you a analogy, right, this is something that I dealt with in 1999, right? In the network that I was, supporting, we were running these routers called GSR routers or Cisco, I think they're called gigabit switch routers. And the CPU in that router had a limited, amount of capacity, and its main job is to pass packets, right? And when it runs up against congestion, you don't want to do anything else except forwarding packets. Right? You don't want to do anything else. And I remember in 1999, we ran into capacity issues, but we needed to understand how our network was performing. And so we turned on this protocol called NetFlow, right? And NetFlow had such high computing requirements that I called it flatlined our CPU, right? It just sucked up all the CPU resources. And what we were trying to understand was what is causing all this congestion? What is the traffic that is killing us? And sometimes you have to do that to understand whether you're being, attacked by a DDoS attack or a malicious malware attack, right?
Right.
And that's basically what's happened when you're being attacked. Someone is sending so many small packets and your CPU is starting to choke or can't keep up. And so your customers, experience major setbacks. So those routers came with a certain amount of CPU, and that's it. That's all you get, right? In the virtual world, you can apply as many CPU cores or as many CPU sockets to a problem as you need on an as-needed basis. And so in terms of service assurance, right, with real-time telemetry and real-time compute applied to your analytics engines, right, you can do whatever you want with it. Like there was a time when I even told my people that we need to turn off ICMP echo, which is ping, right? So if your router's trying to keep up just passing traffic back in the 90s, and you're pinging it and saying, hey, how are you doing? Hey, how are you doing? It's choking. Yeah, and your router's choking and it's saying, leave me alone, I'm trying to pass packets, right? So ping, ICMP echo gets deprioritized because it's trying to pass TCP/IP or UDP traffic. Now, with multiple cores that you can apply to the problem, you have different lanes, right? One lane is doing one function, another lane is doing another function. Look, I used the word lane, but it's actual pods, right? Pods do different things. And service assurance, you can do telemetry real time to automate some things, right? So I'll use the case in point. Let's say when the war in Ukraine broke out a few years ago, energy prices around the world shot up, especially in Europe, right? And so if you'd like to be able to dynamically adjust the amount of power your CPUs or your servers are consuming when delivering, any workload, it could be PON, it could be DOCSIS, it could be, wireless service. You know that there's a cycle, right, where you've got a peak hour and, an off-peak hour period. So if you know that at certain points in the day, you don't need to be powering your CPUs at their, default clock frequency or, consuming the total, thermal dynamic power, right, threshold, total, you can turn down the clock speed. You can turn down the operating parameters of your CPUs. And as such, that affects the power of your server. So during peak hours, let's say 9 p.m., 8 p.m., you got to leave it at the default so that people don't lose packets and your service is as best it can be. But then at 2 in the morning or 3 in the morning, these tools can go in and dynamically analyze, is there any traffic coming across the NIC card? Is there any traffic happening on the network at the moment? And if it's very low, we can fine tune it, adjust it, little by little. And then we get to a point where we're happy and we are now saving maximum amount of power so that, you're not dropping packets, you're not affecting the customer service, but you're saving maximum power. And then you're able to see that, customers are starting to wake up at 6 a.m. and you have to ramp that power back up so that your CPU power is, able to keep up with the amount of traffic coming across your NIC cards. So all of this real-time telemetry and service assurance gets automated, right? People don't actually need to do anything. It's being done by software and it's got the necessary compute to do that. And it's also got some fail-safe, mechanisms in the back so that if for whatever reason a catastrophic event happens and everyone turned on their phones and checked their phone or, goes on Twitter, or goes on, the news, it'll be able to turn itself right back up and the customers don't even see any change in that service. So service assurance is one, latency protections, I think with the amount of compute that is possible, we can understand the conditions of the network in real time. We can apply the knobs and dials and tools to make sure the quality of experience for the end user is optimal during that particular time, right? And I go back to my analogy, right? If the main router's job is to pass packets, 20 years ago, he's not going to answer you when you're trying to ping it and say, hey, how are you doing, right? Today, you don't have that problem. You've got enough compute and you can add more compute as you need it. And you can turn up Kubernetes pods, you can turn up, additional containers or, compute clusters as you need it. If you want to apply it to the core function of passing packets, or if you want to apply it to service assurance and quality of experience monitoring and automation, you can do that. And so, flexibility is great.
Yeah. And, talking about that and you talking about the pods and for all the users that are out there that are watching this video, or the, viewers that are watching this video, when we're talking about virtualization, it's important to note that a lot of these servers run in the Kubernetes structure, run in multi-server blocks called clusters. And there's always redundancy in the pods that are always available looking for services that are going to fail over from another pod. The customer will not see these issues as these things are happening instantaneously, and it's not human intervention at all. It's all just automatically rescaling and removing pods as needed for services that are required. So, talking about the service assurance, that's why virtualization is so important. Even with a single server, you have resiliency inside of that server with pods and services. So there's always a backup to the backup that's happening on those servers. And that's really the high importance of virtualization is that it has the ability to do that. I know that we all have dealt with historically where maybe you took a SNMP dump of data and it locked up a card or it locked up a box, and then you have to reboot it, and then all the services go down, or maybe a process in that box failed, and the only way to fix it is unfortunately to restart it or restart the service. Maybe you don't have to, restart the whole box, but you have to restart the service, which is service impacting. So in this environment, that's not happening. And even to the point that if you lost a whole complete server, all of your customers would be unaffected because of the way that they scale the pods and services on these servers. You're protected. So I think that's a really high importance of what we're talking about today. It's when you look at virtualization, and, if you've never looked into it, I highly suggest it, because for pretty much the whole global market, that's the direction for all services that operators deploy, whether it be fiber or DOCSIS. Everyone is heavily looking at this to move to, just for these very key points of why it's so important. Talking about reliability and SLA, which we know all operators are offering these SLA to their customers today, that, you don't want to have to come back to the customer come to you and say, hey, what's my refund look like this month for my services that were down, right? Nobody wants to have that conversation. We're at 597 and a 5. So almost 6 nines of reliability, which is roughly about, if it breaks it down in people, in just downtime, that's about 60 seconds a year. And that's across all customers that we're using. And Thuy, I don't know if you have any other, reliability points that you could share with us. I kind of threw that on you at the fly, but, do you guys have any metrics around that? And I'm sure you guys do, of reliability aspects for, how Intel's helping operators.
Well, I come from a network operations background. That's where I started in my career. So I typically, think of those metrics that you describe in, mean time to restore, mean time to identify, and, mean time between failures. So, when CFOs or, network operators build their networks, they have several plays, several options at play, right? So you've got the ability to build redundant networks, right? A long time ago, that was very expensive, right? To build redundant fiber rings where, you've got duplicated appliances, duplicated infrastructure, so that when a customer goes down, you switch, they go in the opposite direction on a ring, or, a standby box stands itself up. That's a very expensive proposition, right? And that's to mitigate your mean time between failure, right? Or you buy really, really expensive equipment, that doesn't fail as much, but I guarantee you it will fail, right?
Right, yeah.
But the other side of that equation is, well, the mean time between failures is something that you can control. And the reliability factor is, the reliability equation comes down to, when it does fail, how quickly can I identify, right? And that's in the tools you just mentioned, service assurance. If you can monitor and have good probes and sensors and monitors that help you identify the failure, isolate, and be able to help your people get them the tools they needed to restore service very quickly, right? That's affecting reliability just as much as redundant networks, right? So the mean time to identify, the mean time to restore, right, are both very important in the equation. So now that you're in a software-defined networking world, right, you've got a lot more compute at your disposal. You've got software that is very smart, very intelligent, that can do a lot of this automation for you, right? It recognizes patterns. And as such, you're now able to apply capital that you do buy a lot more efficiently than, buying an extra box that doesn't do anything for, to your point about 5 nines, right? What, 0.01% of the time, things just sitting there doing nothing, right? Whereas in today's world, where you've got very, very precise, ability to turn up more compute, turn up more clusters, and, have high availability failover, because the compute and the software is much more sophisticated. So you ask about metrics. I certainly, measure reliability, availability, and defects, right? When you push software, right, upgrades, right, the ability to do software upgrades in an automated fashion so that you reduce your defects per million, it is huge, right? Like I remember one of the MSOs that, we dearly, love in America, they said that when they switched from legacy to virtual CMTS, they were able to reduce the mean time to identify an issue with their network from, I want to say it was, like 45 minutes or something, down to like single digit minutes, right? And then
Which is huge.
Yeah. And then the ability to restore service is also, reduced by orders of magnitude. But what was also really impressive was that they showed a number that said they made, I don't know, in the order of like 3,000 software changes per month, right? And it's all automated now, right? And sure, they may spend a lot of time in the planning before they, invoke the script to automate, but the defects per million of these software changes went down, I want to say, again, orders of magnitude, right? Where these maintenance upgrades or these, service maintenance windows are not as long as they used to be, which is good for customers. And the defects per million or the unplanned outages has come down significantly.
Yeah. So one thing I would add that we haven't kind of really talked about is, when you're going to the virtualized state, it allows you and gives you the capability to do in-service software upgrades, because it will move the pods after they've been upgraded and move the services back as it needs it to offload and update those pods. So it gives you another added tool to your toolbox to keep your customers online. So I see that being as a key benefit. I'm sure there's other platforms that aren't virtualized that probably can do something similar, but when you're able to do it without any customer interruptions through the whole process, and we're talking, it could be as low as 500 customers, it could be as high as 25,000 customers, or even further than that, right? So I think it just adds another layer of tools in your toolbox for being able to, for operations to be smoother, faster, and more efficient.
Yeah. And I'll share with you a personal, anecdote here, right? Like you asked me about metrics, and one of the key metrics is absolutely the NPS, right? The Net Promoter Score, right? As a consumer, I pay for cable modem service in my home, and we had a power outage, I want to say a couple of months ago in my neighborhood, right? I could clearly see that, all of the houses across the street and, my side of the street, we all lost power. Now, I live in California. We have, solar panels up on our roof. So we have a backup power supply that stores some of that energy. And my Wi-Fi was working. The internet into my home over the cable modem network was still up and running because my cable operator has backup power supplies on their RF plant. And because my home had this, backup battery bank from my solar panels, my cable modem was still powered on, and the RF signal was still good between, me and the cable company's infrastructure. So I wasn't on my 5G network at all. And what was nice was throughout this whole thing, my cable operator was sending me text messages to, my cell phone to say, we've detected a power outage. We, are working to isolate the issue, but, should you have any problems, give us a call, but we see an outage, right? And then when the outage was restored, even though I didn't even have an outage, they sent me a text to say that, we've resolved the issue. And if your service is not up and running, again, give us a call or send us a text. That proactive communication, that customer notification to me was very valuable. And in my opinion, that Net Promoter Score went up for me because I definitely would promote, my cable modem service to my neighbors and, my friends.
Yeah, I don't think anyone wants to, do without internet these days. And even right now, it's highly important. I mean, you're in California, I'm in Tennessee, and we're able to do this and talk to our consumers and, offer tips and tricks of about how kind of the world's scaling. And, it's a highly important thing today. I don't think there's anywhere that we go in the world and we all travel and do all these things, you know, everywhere you look, something is using the internet. It doesn't matter. You can look 5 feet and I promise you there's something that's using the internet. It's just super, super important. Now looking into the future, are there any things that you might consider that could be roadblocks for broadband, whether it be fiber or DOCSIS? Is there anything out there, or what do you consider a roadblock for us in the future?
Well, I'm glad to see that the regulatory, environment has been very progressive in the past, decade, right? Like I think as we saw with the COVID pandemic, right, to your earlier point, broadband service is essential, right? Like, who would have thought that the whole community around us shut down and we were still able to get on our meetings with our broadband connections at home, right? We still conducted meetings, we still worked, from home, and we were all very productive. And that was made possible because of broadband. So the FCC, right, the Federal Communications Commission, decided to change a lot of their definitions of broadband, right? I think the definition is now 100 megabit per second downstream, and I think 25 megabit per second upstream. That's considered broadband. I think that's almost a doubling, right, of what broadband was prior in the last FCC definition. And when they made that change, they also decided to offer up the BEAD, right? So the Broadband Equity and Access, fund that earmarks $45 billion to help make broadband available to as many Americans as possible, right? Not just those who live in urban centers or suburban, markets.
Right.
So the rural markets also deserve broadband, at the definition that the FCC has defined it, 100 megabits down and 25 megabits up. And as such, that's spurring new entrants, right? And that's also giving existing operators incentive to extend their networks, right? To build further reach, to reach customers who are either underserved or unserved today. So I'm very happy to see the regulatory environment improve. Now, earlier you mentioned about rights of way on poles, right? Like, I remember a good friend of mine, my mentor, he worked at Google and was Google Fiber, and they talked about a regulation called, I think, One Touch Make Ready, right? I still remember the days when you had to call like 3 different telephone companies, right? Let's say you call the local the LEC, the ILEC, and the telco, and they all share that pole. Well, guess how long it would take for you to add a device on that pole? You got to wait for all 3 of these companies, right? The local LEC and the ILEC, and all these folks have 45 days to go out and do something. So one guy climbs a pole, he takes his thing down, and 45 days later, another guy comes along and takes his thing down. And so you could be waiting 120 or more days before you can go up to that pole and put your thing up there. And so these kinds of regulations are needed to innovate so that there's easier access to these, I call them street furniture, elements that allows more building and expansion of these networks. So I've often thought that some of the roadblocks and some of the barriers we have are the pace at which our governments, local governments and state governments and federal governments move. But I'm glad to see that it's coming along and it's moving along faster than it was maybe a decade ago. And maybe we have COVID-19 to thank for that, because that was a period where we all proved that broadband is essential.
Yeah, I was an operator during that time period, and you know, a lot of employers in our areas, they shut their offices down. A lot of workforce moved to the home, and everybody really needed it for school, their jobs, maybe checking on family members. So I think that was the turning point where broadband went from an internet service to now I'm hearing it referenced as a utility, just almost as equally as electricity, as silly as that kind of seems, and really the whole broad aspect of it. But it's considered, everybody that you talk to that runs a business, they need they need the key four things, right? Electricity, water, gas, internet. Like that's the main four things they got to have in a lot of cases. So I see the same pain points coming from an operational standpoint that you're referring to, and I do think that it's getting better. And I think in a lot of cases, a lot of states are governed, their bodies of some of that controlling fact is state to state. But I think overall, in general, that is becoming a lot easier for operators to be able to get those things done as well. So that was kind of my last question of the segment. Now, I wanted to, and I kind of pitched this question at the end of every discussion, because I want to get your opinion, because I know you really like what you do, and you wouldn't be doing it if you didn't like it for as long as you have. So what do you love most about working in broadband or in this industry?
I look back and I can smile when I think of things that we didn't think were possible, right? Like I look back to the days when emails were just text, right? And then we started attaching photos as attachments in our emails. And then we started being able to make phone calls, right, on our broadband connections. And suddenly, remember when it used to cost us a lot of money to make long distance phone calls, and
Right.
you had to pay, like really big amounts to, call an international caller, right? And today, I don't know, I use WhatsApp and I use Facebook Messenger to call my family in Vietnam, my sister in Vietnam, or, my friends and family in Europe. And there's no additional cost, right? All of that has been made possible because of voice over IP and because of delivery of services over IP. And that's the power of broadband. And as I, look back to things like, music, I remember the heydays of Napster, and we've changed the way the music industry operates. The recording industry,
Right.
Has had to change how they deal with, the rights management and the content that they produce. And I think broadband has had such a profound effect on, our communities around us, that I'm proud to have been a part of that. And I've been proud to be, in the midst of things breaking every day, because we didn't know what was happening, right? Why did that happen, right? And it turned out because of Napster. Like people were, downloading, content that, someone put out on the internet. And then, the whole email, being able to send pictures, and nowadays we can do, FaceTime calls with each other around the world, and it's just part of what you pay in your monthly, broadband internet service bill. You don't have to pay, the long distance bills, and you don't have to, have different devices and different, services for all these things. And of course, we go back to my ability to be able to work from home now. Like I'm just as productive here as I am at the office. I still like to go to the office to, see people and actually, give people a hug, as our CEO says, or shake hands. But for me, the ability to get on a call or a meeting and start that call at my desk, and I go in my garage, back out of the car, that phone call is still seamlessly, connected. And as I drive away, I'm now on a 5G network, and I'm still able to participate on that meeting seamlessly, right? The network doesn't know that I switched from my home broadband to my 5G, cellular, service. I'm still on that same, meeting hosted by, a web conference bridge that is running today. Now, what I do at Intel is very exciting. I'm very pleased that, Intel invested in this segment, 8-9 years ago. And I've been lucky to be able to support the innovation and help the ecosystem embrace, common off-the-shelf compute to do all the things that the cable companies do to deliver this broadband service. And as I look to the future, I hope that, virtualization and the success that cable operators and telcos see in virtualizing their networks will encourage them to continue to push more virtualization deeper into the network, edge compute, and the ability to leverage Moore's law and be able to do more, with the same CPUs that, they buy every year.
Yeah, it's this industry is evolving at a rapid rate, and I've always said I enjoyed even from the operational aspect of the operators that I work with now, being thrilled about the services that they're able to offer their customers. I actually get to see that with end users sometimes in these markets, and even in my own home with my own family. Operators, if we have an operator that's watching today, we really applaud you guys for what you're doing out there in the world. Without you guys, none of this would be possible. And you guys are doing a wonderful job and making the quality of life for consumers the best that it possibly could be. So we appreciate you all, and Thuy, thank you for joining today. I know that time is very important, but we greatly appreciate your time and insight into today's session.
Thank you, Dustin. It's been my pleasure. And, you brought up some excellent topics, so I appreciate you hosting me here.